Good morning everyone, this is Dr. Mema Ghazal. Today in this video we will talk about thermodynamics. In a previous video we already talked about the basic concepts and the terms which are used and important in thermodynamics. We will first talk about the changes which the thermodynamic system possesses. So out of those changes, the very first change which here I am discussing, that is reversible change. Reversible change is that kind of a change when a system or when a substance is allowed to regain its original shape when transforming and when changing the physical appearance as well. So it is easy to turn it back. So that's why it is said to be the reversible change. Here you can see this picture that when we put some water in a freezer or a refrigerator, it will turn into ice cubes. Then again we allow that water to warm and melt, and then it again changes back into water. So this kind of a change is said to be the reversible change when a substance is allowed to regain its shape and to allow to change the physical appearance, then it is said to be the reversible one. In that reversible changes that they are changing the states of a substance. Just like solid to liquid, liquid to gas, gas to liquid, liquid to solid. And reversible changes does not change the amount of matter in the substance, and it will not give you an idea about the new substance which is going to be produced when we are talking about reversible changes, because this is not the phenomena of reversible changes where you are getting an idea that a new substance is forming, because reversible changes are having a tendency that they are again regaining its original shape. Just like in another picture you can see, because I am giving the daily life example, so it will be easy to understand the concepts which are related to thermodynamics purely. So here you can see that we are having a chunk of a chocolate. When we are allowing the chunk of a chocolate to heat, so it is became in this particular physical state. Then again we are allowing this melting situation or melting base chocolate liquid to cool, then it again regain its original shape. So in this way, reversible changes are having a tendency to do not produce new substances, but they can transfer the physical state of that substance, and that substance will not be allowed to change the amount of matter which is present in that. So these kind of changes are also very important when we are talking about any system which is having that thermodynamic properties. Another change which is very important in thermodynamics, that is said to be the irreversible change. Irreversible by its name also you can see that the irreversible change, that once it will gain the another position or another state, then it is very hard to regain the original shape. So some of the examples which I am giving here, so it will be easy to understand what kind of irreversible changes are occurring in a thermodynamic system. Just like when you are having the cement powder and water in cell, and you are allowing them and you are mixing them very well, then you are finding a mixture to be, and leave the mixture to stand. It will set hard and the new substance water is formed. Means the thing is like, when we are talking about when we are mixing three different substances together, so that three different substances will give you a new substance. The formation of new substance will take place, that will be in a form of a mortar, and that substance will not allow again to regain the original shape. So that's why these kind of changes are said to be the irreversible changes. Some other examples of irreversible changes are, you cannot change a cake back into its ingredient. Means when you are mixing all the ingredients and baking a cake, so once it is gaining this kind of a shape or a position, after that what happens, that you are not, means that particular cake you are not able to split into the ingredients which you mix to make a cake. So this is also a kind of a irreversible change. In the same manner, when we are talking about irreversible changes, so frying or heating. When you heat a raw egg to make a cooked egg, and the fried egg cannot be changed back to a raw egg again. So this is called the irreversible changes, which we can see easily in various thermodynamic systems. Now we are going to talk about processes. Thermodynamic processes and different types of processes. First, we will talk about what is actually the meaning of a process in a thermodynamics. So, process is a kind of a operation or a method which occurs in a system when any sort of change or transformation, which can be chemical or which can be physical, takes place. During the process, what happened? The system goes from the initial state to a final state through an intermediate series, and these series is called as path of the process. So in this way we are having different kinds of processes a thermodynamic system possesses. So basically process is a kind of a operation or a method on which will give you an idea about the chemical or a physical transformation which is taking place in a system, and that is acquired by a different paths. So in this way, thermodynamic processes has been classified in different varieties or by its name. So you can see here also the very first process is said to be isothermal process, which is related to temperature. So in isothermal process, what happened? The temperature of a system remains constant, and the heat can flow from systems to surroundings and vice versa in order to keep the temperature constant. So when we are talking here about isothermal, by its name it depends on temperature. Isochoric, by its name, it depends on volume. When you are finding a system where you are finding the volume or the quantity of the material which is fixed or inserted in a system remains constant. Adiabatic process, by the name you can see that it is related to heat. When a system does not exchange heat with the surroundings and system is completely insulated with the surroundings, then at that time, at that position is said to be the adiabatic process is going on in that particular system. After that, isobaric system. Isobaric system is totally related to pressure. Pressure of a system, when you are finding the isobaric process is going on in a system, then at that time the pressure of the system remains constant during the process. And the last is said to be the cyclic process. Cyclic process, the famous example of cyclic process is Carnot engine or Carnot cycle, where you are finding that a process which is undergoing a series of changes and finally returns to its initial state. If we are taking this plot as an example, and if we are pointing out like this, the very first point is said to be A, then B, then C, and then D. So cyclic process will start in this way, like it is covering the path of A to B, B to C, C to D, and D to A, again to regain the original destination, which is A here. So cyclic process is that kind of a process which a system possesses and which undergoes a series of changes and finally returns to its initial state. So cyclic process is also said to be a kind of a reversible process as well, because the system is again regaining its original state or the physical or by going through a physical or chemical transformations, and it is again regaining its initial state. So that's why it is said to be a process. Now we are going to talk about all these processes in terms of pure thermodynamics types. Here you can see that when we are talking about isothermal process, so those processes in which you are finding that your temperature is fixed, and that's why it is said to be isothermal. So it may achieve by placing a system in a thermostat where you are finding that dT equals to 0, means like a small slight change in temperature will come and it will give you an idea that your temperature will be constant. Adiabatic process, where you are finding that your heat flow heat is not allowed to flow into or out of the system. That's why it is said to be adiabatic process. And the conditions on which this approached by carrying the process in an insulated container or thermo bottle, you can easily see this particular process. In this process, what happened? Heat evolved increases the temperature of the system, and heat absorbed decreases the temperature of the system. Now we are going to talk about isobaric process in detail. So isobaric process are those kind of process where you are finding the pressure of a system remains constant throughout the period of change. For an isobaric process, the change in pressure is equals to 0. For example, reaction takes place in an in an open system, and 1 atmospheric pressure is isobaric one. So after we will talk about isochoric process, which is related to volume, which I have already told you that where you are finding that you are having a system, the volume of the system will be constant during various operations of the changes in the state of the system. For such changes, your dV or del V equals to 0. So reaction taking place in a sealed container is one of the famous example of an isochoric process. The last process is said to be the cyclic process, when a system in a given state through going through a number of different processes and finally return or regain its initial state. So at that time the overall process is said to be the cyclic process or cycle process or reversible process, where in that cyclic process you are finding the change in the internal energy, which is equals to 0, as well as the enthalpy, which is also equals to 0. So by these plots also you can find that what kind of a processes are going on. If we are plotting a graph between pressure and volume, so for basic thermodynamic process you can see here that if it is isochoric process related to volume, it is isobaric process related to pressure, it is isothermal process related to temperature, and it is adiabatic process related to heat. Heat we are denoting by a symbol Q. Here in this another plot you can see that again we are plotting a graph of pressure versus volume, where we are displaying the cyclic process. If I am assuming that I am having this initial state A, B and C, so this whole system is going through these different processes and again regaining its original state. Isobaric process between the path A to B, then B to C isochoric process, then C to A, this one adiabatic process. So this particular system possesses various different paths with very different processes, and after again going to regain its original state. So this is all about the processes which are playing a very important role in thermodynamics, and by the basic knowledge of these processes only a system can be easily understood. So in this video this is all about the process. In my next video we will talk about work, heat, energy, another parameters which are also important for thermodynamics. So have a good day and bye for now. We'll meet again and we'll discuss about thermodynamics more.